Hey everybody, this is Larry. This is day 12 of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, which is loading. Number of steps to reduce a number to zero. Yes, I usually solve these live, so if it's a little bit slow, just fast forward and hang out or whatever you like. Okay. So given a non-negative integer num, return the number of steps to return zero. Okay. If it's even, you have to divide it by 2, otherwise you have to subtract from it. Okay, so there's no decision, right? So we just do it. I don't know what the tricky part about this is. Um, I mean, this is going to be log n, where n is the input number, because you're going to, at most, if it's an odd number every time, it's just going to be 2 times log n or something like that. It's just, yeah. I don't know if there's anything tricky about it even. I think the tricky part, if you got it on an interview or something similar, is around the complexity and just try to able to explain it. I don't think implementation wise there's anything tricky, because it literally just gives you the rule, right? So because of that, I'm going to, unless I misunderstood it or something. So you have this like count equals 0, well num. I mean, and actually there are a couple of in theory shortcuts that you can do in Python, because this actually reduced to counting the number of ones and zeros and digits and something like that. But because I think it's just the number of digits plus the number of ones in the binary representation. But that said, we can just do it. So yeah. I mean, you could just simulate it if this is else. And you could kind of prove, and you could look at this formula, and some of that maybe is just practice, is that you could look at this formula and kind of reduce that to what I said earlier, which is counting the number of ones plus the number of digits. Because if you look at just the last digit, if it's a 1, it becomes 0 in one step, and then you have to remove the 0, right? So you keep on doing that for every you do it for every digit except for the first digit, I suppose. So it's like something like that, as the number of zeros or number of digits plus the number of ones, maybe minus 1 or something. So you could definitely reduce that, but and because of that, you can kind of figure out from that visualization, if you will, that this is going to be log n, or 2 times log n in the worst case, where n is the input number, which is in theory actually linear in the size of the input, because the input is the number of bits, right? And in that same count, you want to call it that, it's constant space or linear space, depending on how you want to do it, because you could also make an argument that, like this takes an extra space because we technically modify, or it gets copied by value or whatever. I mean, it gets a little bit tricky when you do number of bits as the input. But yeah, this is accepted, and I think my tricky part is just try to figure out what this problem is asking, because it seems really easy. Yeah, this is the hint, right? I don't even know, but yeah, I think the idea behind the other answer is that you look at the number and you have some binary representation. If the last digit is 0, well, we divide by 2, which means that we remove it. If the last digit is 1, that means we change it to 0, and then we remove it. So that's basically how I get that idea. And then you keep on doing it, and eventually it's just the number of digits plus the number of 1, maybe minus the 1 for the last digit, because 1 goes to 0, and you're already done, right? So maybe minus 1 there, assuming there's no leading 0, which there is. So maybe there's a special case, like I said. But yeah, otherwise linear time, linear space, kind of, um, where the size of the where the input size is the number of bits, right, or number of bytes equivalently. Um, yeah, but O of log n for time, O of 1 for space, but it's kind of it's kind of weird to say O of 1 for space when you take that number into account, because it also takes O of log n to represent the number of bits, right? So as long as you're consistent, I think that's okay, which is to say either you say linear time, linear space, or O of log n time, O of log n space, or O of one time, O of one space. And the O of one comes from the fact that the input is less than, 2 to the 32. So then, it's always going to be less than 32 operation or something like that. I don't know. I mean, that's just up to you. I mean, I think if you understand all the concepts that I talked about, then you're able to articulate the different ways of thinking about the complexity. And as long as you do that, then it doesn't really. I mean, you have to communicate it though, but it doesn't matter exactly how you phrase it. Yeah, that's all I have for this problem. I think it's. I think I just. I don't know. I thought there'll be a trickier problem, so I didn't really. I was confused by the fact that it was too easy. Um, like, yeah, if this was a Q1 on a contest or something like that, I'd probably get it in about 3 seconds, maybe a minute, because I always test my stuff because it's not worth not testing your stuff for an extra 20 seconds because it costs you 5 minutes uh, if you have a typo. But yeah, that's all I have for this problem. Have a good night. Take care of yourself. Take care of others. Stay good. Stay well. You know, and to good mental health, and also Happy New Year for those of you who celebrate on the lunar calendar. I'll see you tomorrow. Bye bye.